Okay, bonding in coordination compound. So, how the bonds are formed between the metal and the ligand? You can explain that bonding by applying valence bond theory. By applying VBT, you can explain the bond formation. Actually, during the bond formation between the ligand and metal undergo hybridization and it will form some hybrid orbital, vacant hybrid orbital, and in that vacant hybrid orbital, that ligand donate the electron pair. So now, I'll take one example. Suppose NiCO whole 4. Its name is tetracarbonyl nickel. So in this complex, if you want to find out the structure of the complex, if you want to find out the magnetic property of this complex, then all this property you can find out by considering the type of hybridization of nickel. So now I'll find out what type of hybridization shown by the metal nickel. This is the complex NiCO whole 4. Its name is tetracarbonyl nickel 0. Here oxidation number of nickel is 0. So here, as you know, nickel atomic number is 28. So its electronic configuration you can write like this: argon means 18 gone. Then you have to write 4s2. Then after that you have to enter the electron in 3d. So 18 plus 2 20. So 8 electron remain. That's why 3d 8. And this is the electronic configuration of nickel. So since here nickel is 0 oxidation state, I mean nickel do not have any charge. So the electronic configuration of nickel will remain same. But suppose in this case nickel is 2 plus, then you have to write the electronic configuration of nickel 2 plus. I mean you have to remove 2 electron like that. So here nickel is 0 oxidation state, that's why electronic configuration remain like this. Now I will show you the valence configuration. This is 3d8. As you know, there are 5 d orbitals. These are the d orbitals of nickel, and this is the 4s orbital. And after that you will get the 4p orbital. This is vacant 4s, and these are 4p, 4px, 4py, 4pz, like that. So 3d contain how many electron? 8. So 1 2 3 4 5 6 7 8 electron. 4s contain 2 electron. It will be like this. So this is the electronic configuration of nickel. Now, electronic configuration of nickel in the complex tetracarbonyl nickel. Now here, when the ligand comes towards this metal, then metal will form some vacant orbital. Here you have seen only 3 vacant orbital. These are vacant orbital. But here how many ligands? There are 4 ligands. So since it is monodentate ligand, they can donate only 1 pair. So 4 ligands will donate 4 pairs of electron. So that's why the nickel should produce 4 vacant orbital to accept the electron from the ligand. So now here what is the ligand? Carbon monoxide. Always you remember, carbon monoxide you will get later. Cyanide, this type of ligands are called very strong ligand. These are the example of strong ligand. You will get later why they act as strong ligand. These are very strong ligand, and if this type of strong ligands are present, then if some unpaired electron is present, then they undergo pairing. This will happen only in presence of strong ligand. If the ligand is weak, the configuration will remain same, no pairing takes place. So here the ligand is strong, that's why 1 electron from 4s will come towards this orbital to get paired, and another electron comes towards this orbital to get paired. So ultimately in the nickel configuration, the 3d orbital becomes paired like this, and 4s become vacant. It will happen due to presence of strong ligand. This is 4p. So now 4s is vacant, 4p is vacant. Here we have 4 ligands. So 4 ligands will donate 4 pairs of electron, and that's why 4 vacant orbitals are required. So here 4 orbitals are available, and these 4 orbitals, they undergo mixing. And this mixing of orbital is called hybridization. I mean they undergo hybridization. Since one s orbital mixed with another 3p orbital, that's why this type of hybridization is called sp3 hybridization. So after hybridization, they will form some hybrid orbital. The 3d will remain same. This is 3d orbital. It do not involve in hybridization because these are filled up by electrons. When they mix up, they will form 4 orbital mix up. That's why they will form 4 hybrid orbitals, and these hybrid orbitals are named as sp3 hybrid orbitals. Why they are called sp3? Because one s orbital mixed with 3 p orbitals. That's why the hybrid orbital named as sp3. And why it forms 4 orbitals? Because 4 orbitals involved in mixing. I mean, number of hybrid orbital produced is equal to the number of orbitals involved in mixing. Now, after production of these 4 hybrid orbital, now the ligand will come. What is our ligand? Carbon monoxide. So when carbon monoxide will come, this carbon monoxide donate the electron pair to the metal, and the electron pair will enter inside the vacant orbital of the metal, vacant hybrid orbital of the metal. So like this way, the bond will form between the metal and the ligand. So first time the metal will form some vacant hybrid orbital, and when the vacant hybrid orbital will produce, then the ligand will donate the electron pair to that vacant hybrid orbital. And how many hybrid orbital it will produce, it depends on the number of ligands. How many electron pairs will come, based on that it will form the vacant orbital, and in that vacant orbital ligand will donate the electron pair. So in this complex tetracarbonyl nickel, the hybridization is sp3 hybridization. You have got sp3 hybridization takes place, and due to sp3 hybridization, the shape of the complex will be tetrahedral. The shape of the always sp3 produce tetrahedral, dsp2 produce square planar, d2sp3 produce octahedral, like that. So sp3 always produce tetrahedral shape, and here after hybridization there is no unpaired electron present in the complex, all are paired electrons, and that's why the complex is said to be diamagnetic in nature, since there is no unpaired electron, and that's why the complex is said to be diamagnetic. But after hybridization, if some unpaired electron is remain here, then the complex is said to be paramagnetic complex. So like this way you can find out the type of hybridization, the structure of the complex, the magnetic property of the complex. And always you remember, carbon monoxide, cyanide, these are very strong ligand. If this type of ligands are present in your complex, then this type of pairing takes place. Weak ligand cannot do this type of pairing. So this is one of the example. Pause.